Hi grade 11s, welcome to this new topic, financial maths. This topic is part of paper 1 and it's really a really nice topic because it's practical to everyday life. It's something that you can use, and in matric it gets even more exciting. So grade 11 financial maths starts to get really fun. It's there's quite a lot of new stuff compared to grade 10, and it really is quite a nice section. So topic 1 is just basically a recap of simple and compound interest. So things we should probably know from grade 10 already. Right, so let's start with our two formulas. First of all, this formula that I've put in first here is the simple interest formula. And let's just quickly remind ourselves, what is simple interest? So simple interest is quite rarely used in the real world. There are a couple of cases that we will use simple interest for. But simple interest is where interest is calculated on the original investment every single time. It could be the original loan or the original investment, depending on what you were doing. So interest is calculated on the original amount. I'm just going to say amount because it could have been a loan or an investment. Now the reason why this doesn't work in the real world is that your investment is constantly changing. Your loan hopefully is constantly changing because you're paying it off. And so why would you want to get interest on the original amount every time? And so there's certain cases where we use simple interest, which I'll say in a moment, but it isn't widely used in the banking world. So just a note again, interest is calculated on the original amount. Now that if it's calculated on the original amount the whole time, the original amount never changes. So what this means is it means your interest is the same every time. It remains constant. So if it was an annual interest, then every year you would earn the same amount of interest, or you'd have to pay the same amount of interest. Okay, now let's just quickly note when we actually do use this in the real world. Often loan sharks will use simple interest because it means even if you're paying off your debt, they're charging you interest on their original amount, and so they're earning more money. That's why they're called loan sharks, because they're not particularly nice. And another time that we use simple interest in the real world is something called hire purchase. Now, we don't do hire purchase a lot in grade 11 because it's very much a grade 8 and 9 and 10 topic, but that's when you go to the shops and you need the TV but you can't afford it cash. So you take the TV and then you pay it off over 36 months. And what they do is they charge you interest on the original amount all the time, even though you're paying off. And the reason why they do that is because ultimately you'll end up paying sometimes double for the TV. So it's a bit of a money-making thing, hire purchase. So let's have a quick look at what all these letters stand for. Technically, A stands for accrued amount. Now, if you do accounting, you would have known that word. So accrued amount basically means to accrue something means to build up something. So I always think of my accrued amount as my final amount. Now, I'm actually going to draw an arrow from the compound interest formula as well, because the A stands for the same thing in both. Okay, P stands for your principal amount, as in your original amount. That's why it's a P, because technically it's a principal amount. So that could be the original amount of your loan or your original amount of your investment. Now, always note that in the cases of interest or growth, your P always has to be smaller because your money always grows to something. So, we hope. But these formulas only ever grow money. So your principal amount will always be smaller than your accrued amount. Okay, I stands for your interest rate. Now, interest rates are always given as a percentage, which means it's out of 100. So we'll notice, I'll talk about it when I actually use interest rates in a moment. You can use the percentage sign on your calculator, or you can write it over 100, or what I prefer to do is write it as a decimal, but it's up to you. Now, most people in grade 10, 8, and 9 think that N stands for number of years. And that's true in grade 8, 9, and 10 because we only ever add interest every year in those grades. Now, the reality is in life, interest can be added at any stage. Interest can be added monthly, it can be added every 6 months, etc. So that's going to be a focus of grade 11. So N doesn't stand for number of years, technically. It stands for number of times interest is added. So often that is number of years because you get interest every year, and so you get If it's 3 years, you get 3 sets of interest. So we're going to talk around n quite a lot. Technically, it's the number of times interest is added. Sorry, I didn't write that very neatly. Okay, now in the other formula, I'm not going to rewrite that because A, P, I, and N stand for exactly the same thing. So what's the only difference in this other formula is this is your compound interest formula. Now this is how most of the real world works. Most of the real world works where interest is calculated on your current balance all the time, and that's compound interest. So that means that if your loan amount has changed, your interest amount will change because your interest is calculated on your current balance. Now this is good for people. Compound interest is very good because if your investment is increasing, then your interest will be then calculated on a bigger amount every time, and so you actually earn more money. And with loans, if you're paying off your money every month, you don't want to be charged interest on the original amount. That's not fair. You want to be charged interest on what you currently owe, and so hopefully every month or every year that's getting smaller, and so your interest will get smaller. So what this means is your interest changes every time, because as long as your current balance changes, then your interest will change. And the only difference in the formulas, as you can see, is here n is my exponent, whereas in the simple interest, it's within the bracket. Right, so those are my formulas. That's what they stand for. We should have derived them in grade 9, so you don't have to remember where they came from at all. Most people don't. The most important thing is, can we use these formulas? So let's go look at some examples together. So example number 1 says, 100,000 Rand is invested in a pension fund. The total in the pension fund at the end of 10 years is 250,000 Rand. Calculate the interest rate if it is compounded annually. So that means it's compound interest. So the moment I see compound interest, I write down my formula. A equals P, 1 plus I to the n. It's given to you on your formula sheet, and so you don't have to worry about remembering it. And personally, I write down what is called a shopping list. So I write down all my letters and I say, right, what do I know? And then I read the question again. So 100,000 Rand is invested. So that must be my original amount, which is called my principal amount. The total in the pension fund after 10 years is 250,000. So that's my accrued amount, my final amount in the future. Calculate my interest rate if it is compounded annually. Well, they said after 10 years. So that's 10. So all I go and do is I go and substitute into my formula, and then this question actually becomes an equation question more than anything else. So now I have to figure out how to solve this equation. So first of all, you get rid of everything furthest away from your I. So I would get rid of my 10,000 first. Now you don't actually have to show, my 100,000. You don't actually have to show the step, but just so you know what I'm doing, I'm going to divide both sides by 100,000. So if I divide both sides by 100,000, I get 2,5 or 5 over 2, but I'm just writing it as a decimal to the power of 10. Right, so next question is, what is furthest away from I? What do I have to get rid of next? Now you can't get rid of this 1 because it's all raised to the power of 10. Now we've probably never solved an equation like this before, but how do I get rid of how do I get rid of raising something to the power of 10? I'm going to take the 10th root. So if I take the 10th root of this side and I take the 10th root, again I probably wouldn't write that in an exam, I would just do it, but just so you know what you've done when you're studying from this. So when you take the 10th root, the 10th root of to the power of 10 cancel each other out, and I simply get 1 plus I. And now this bracket that was around this 1 plus I kind of now is not really needed. Now the problem is when you 10th root something on your calculator, you get like loads and loads and loads of decimals, and I'm afraid you have to keep them, because even more than 2 decimal places, because I'm going to eventually have to multiply by 100 because this is a percent. So do keep that. Try and use the answer button on your calculator now, because I now need to get rid of this 1. So I'm basically going to minus 1 on both sides. So then I get 0,095958 blah 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 blah. So I use the answer button on my calculator, so I said answer minus 1, and so it keeps all the decimals for me. Now that equals I. Now that looks like a very strange I value because it's so small, And that's simply because it's not written as a percent yet. So if you want to write it as a percent, you need to times by 100 to get a percent. And so this is why it's important to keep all the decimals, because when I times by 100, this moves and I get 9,5958% is equal to I. Now I just wrote out a couple of decimals so we can see how to round it, because now the 5 will round the 9, but the 9 has to round up now to 10, so that rounds the 5. So this actually, to 2 decimal places, rounds to 9.6 or 9.60%. Notice the 8 doesn't play a role in the rounding. The third decimal tells you to round the second, and in this case the second had to round up to 10, so that rounds the first. So we get 9.6% interest. Now that's generally, your interest rates generally range from about 6% into maybe 25 at the most. If you get something like 59% interest, nothing in the real world ever works on that type of huge interest. So always go and check your maths if you get something which doesn't seem believable. Okay, let's try our next example. 100,000 Rand is invested in a pension fund. The total in the pension fund after a certain number of years is 287,500. If interest was 12.5% per annum, simple interest. So the moment I see simple interest, I write out my simple interest formula and I write out my shopping list. Now the question says at the end, how many years was it invested for? So now I'm solving for n. So 100,000 Rand was invested, so that's my principal amount. It grew to 287,500. And my interest rate, now this is where you can use different ways to explain this interest rate. You could say 12.5 over 100. Now personally, I don't like that because I don't like percentages. I don't like fractions. I also don't like percentages. So I personally wouldn't, I probably wouldn't write it like that, because then my formula has a fraction in it. You could, because you have a percentage button on your calculator, you could actually just use the percentage button. Or personally, I prefer to put this in on my calculator and then change it to a decimal. So this is 0,125. So in all of my questions, you'll always see me write it as a decimal. Now when you get to matric and the questions become quite chunky, it definitely is easier to have a decimal and not a fraction. And even a percentage can get a bit confusing sometimes. So I'm now going to go and substitute, and I'm going to say, oh, I didn't mean to write, I thought I was going to write A, but I know what A is. A is 287,500 is equal to 100,000, because that was my principal amount, 1 plus an interest rate of 0,125, or you can write any of the others that you wanted to, times n. And again, this now becomes an equation question more than a financial maths question. So I'm going to get rid of my 100,000 Rand first. So I'm going to divide by 100,000 Rand. I definitely wouldn't write this in an exam. I would just do it. But just so we've written down what we're doing for when you're studying and you've forgotten what you were actually doing in these steps, that gives me 23 over 8 on my left hand side. Now sometimes I don't like to write 23 over 8 because then it's a fraction. So often what I will do is I'll change that to a decimal. So it's 2,875 equals 1 plus 0.125n. Now you noticed I've dropped the bracket because I don't really need the bracket. So now what I'll do is minus 1 on both sides. So I get 1,875 equals 0,125n. And now I'm simply going to divide by 0.125 on both sides. Again, you don't have to write these steps. You're welcome to just do it on your calculator. But I'm just writing them in for when you're studying. And I got 15 years, which seems kind of plausible. And it's good that I got a nice whole number, because until we get to matric, the chances of you getting a kind of fraction answer are quite rare, because after a whole number of years it would rise to this amount. Great, so that's just a bit of a quick introduction to the formulas, to what simple interest is and what compound interest is, and then just 2 quick examples on how to use them.